Far beyond the warmth of the sun, in the dark outer regions of our solar system, orbiting the giant planet Jupiter, there exists a frozen world that should be completely lifeless. Its surface is locked. Beneath an endless shell of ice, temperatures plunge to nearly -256 degrees Fahrenheit, and powerful radiation constantly bombards the landscape. At first glance, this distant moon looks like nothing more than a silent, frozen wasteland drifting through space, a place where nothing could possibly survive. But beneath that frozen surface, hidden far below layers of cracked ice, scientists believe something extraordinary may exist. An enormous ocean, not a small lake trapped under ice, but a vast global ocean, containing more liquid water than all the oceans on Earth combined. This mysterious moon is called Europa, first observed in 1610 by the astronomer Galileo Galilei. Yet for centuries it remained nothing more than a tiny point of light, seen through telescopes. No one imagined that beneath its bright, icy shell, an entire alien ocean could be hiding in darkness. Everything changed in the 1990s when NASA sent the spacecraft Galileo mission to explore the Jovian system. As the spacecraft repeatedly flew past Europa, its instruments began revealing something strange. The moon's surface was covered with enormous cracks, long ridges stretching across thousands of miles, and chaotic regions where the ice appeared broken and reshaped. It did not look like a solid frozen crust. It looked restless, almost as if the surface itself was slowly moving. Even more intriguing, Galileo detected an unusual magnetic signature surrounding the moon, a signal that scientists believe could only be explained if a massive layer of salty liquid water existed beneath the ice. If this hidden ocean truly exists, then Europa may be one of the most important worlds in the entire solar system. Because wherever liquid water exists, there is always a possibility, however small, that life might exist as well. And deep beneath miles of alien ice, in total darkness, Europa may be hiding one of the greatest discoveries humanity has ever made, an ocean that could already be alive. The possibility that a vast ocean may exist beneath the frozen crust of Europa becomes even more intriguing when scientists examine the moon's strange and fractured surface, because unlike most icy worlds, in the outer solar system, Europa appears surprisingly young and constantly reshaped when spacecraft first captured detailed images of Europa. During the Galileo mission in the 1990s, researchers noticed something unusual almost immediately. The surface was not covered in large impact craters like many other moons. Instead, it was crisscrossed with long, dark lines, enormous ridges and fractures stretching across thousands of miles, forming a complex network that wraps around the entire moon. These cracks are known as lineae, and they appear as if the icy crust has been pulled apart, shifted, and then partially refrozen over time. In some regions, the surface looks even more chaotic. Massive blocks of ice appear broken, rotated, and frozen again in completely different positions, almost like pieces of a shattered puzzle, slowly drifting on something beneath them. Scientists believe these chaotic terrains may form when warmer water or slushy ice rises from below, weakening the surface until large plates of ice collapse and move before freezing again. But what could cause such movement on a world that should be frozen solid, orbiting nearly 390 million miles from the sun around the giant planet Jupiter? The answer lies in the powerful gravitational forces of Jupiter itself. As Europa travels along its slightly elliptical orbit, Jupiter's immense gravity constantly stretches and squeezes the moon, a process known as tidal flexing. This gravitational tug-of-war creates internal friction deep inside Europa, generating heat beneath the icy shell over millions of years. That heat may have been enough to keep a vast layer of water from freezing completely, allowing a hidden ocean to remain liquid beneath the surface. computer models and observations suggest that Europa's outer ice shell may be between 6 to 19 miles thick, while the ocean below. It could extend nearly 62 miles deep, making it one of the largest bodies of liquid water in the entire solar system. And if that ocean truly exists, then the cracks and ridges covering Europa's surface may actually be the fingerprints of something incredible happening far below. The slow movement of an alien ocean, pushing against the frozen ceiling above it, reshaping the moon's icy skin over millions of years, hinting that beneath the silent frozen landscape, Europa may not be as lifeless as it appears. If the strange cracks and shifting ice plates on Europa are truly signs of an ocean below, then the next question becomes, even more important, how do scientists actually know that this hidden ocean exists? After all, no spacecraft has ever drilled through Europa's thick shell of ice, and no probe has directly touched the water beneath it. Yet, despite that, powerful scientific evidence suggests that the ocean is very real. The most convincing clue, again, came from the spacecraft Galileo mission, as it repeatedly passed close to Europa while orbiting the giant planet Jupiter. During these flybys, Galileo carried instruments designed to measure magnetic fields around the moon, and what it detected was something scientists did not expect. Europa appeared to generate its own changing magnetic signal, but the moon itself is too small and too cold to have a molten metallic core powerful enough to create such a field. So researchers began searching for another explanation. Eventually, they realized that the signal could be produced if a massive layer of electrically conductive liquid existed beneath the surface, specifically a deep ocean of salty water, as Jupiter's powerful magnetic field sweeps past Europa during its orbit. It would naturally induce electrical currents inside that salty ocean, and those currents would generate the magnetic signature detected by Galileo's instruments. In other words, Europa behaves exactly like a world, with a hidden global ocean beneath its icy shell. Additional evidence soon appeared, from other observations as well. High-resolution images revealed regions where the surface seemed to have broken apart and then refrozen, suggesting that warmer material from below had pushed upward through the ice at some point in the past. Even more intriguing, scientists studying data from the Hubble Space Telescope later reported possible signs of enormous water plumes erupting from Europa's surface, similar to geysers, shooting vapor hundreds of miles into space. If these plumes truly exist, they may be tiny leaks from the hidden ocean below, allowing material from that mysterious environment to escape through cracks in the ice. And if that is happening, then Europa is not just a frozen moon. With an ocean trapped beneath it, it may be an active world, a place where water from a dark alien sea occasionally bursts into space, carrying with it clues about what might be living far below the icy crust. But even if a vast ocean exists beneath the icy shell of Europa, another critical question immediately follows. Could anything actually survive there? Liquid water alone is not enough to support life, because every known ecosystem also requires a source of energy on Earth. Most life ultimately depends on sunlight. Plants and microscopic algae capture energy from the sun through photosynthesis, forming the foundation of nearly every food chain on the planet. But Europa's ocean lies buried beneath miles of solid ice, completely cut off from sunlight, locked in permanent darkness. At first glance, that might seem like the end of the story. A beautiful ocean, perhaps, but one that is lifeless and silent. Yet over the past few decades, scientists have discovered something remarkable. Here on Earth, that changed this assumption forever. Deep within our own oceans, thousands of feet below the surface, where sunlight never reaches, entire ecosystems exist around hydrothermal vents on the seafloor. In these extreme environments, superheated water rich in minerals rises from deep inside the planet, creating pockets of warmth and chemical energy that support thriving communities of bacteria, tube worms, shrimp, and other strange organisms. Instead of relying on sunlight, these organisms use chemical reactions in a process known as chemosynthesis, converting minerals from the vents into energy that sustains the entire ecosystem. This discovery forced scientists to reconsider worlds like Europa. If similar hydrothermal activity exists on Europa's ocean floor, then the Moon might possess exactly the ingredients needed for life. Europa is constantly stretched and squeezed by the immense gravity of Jupiter, in a process known as tidal heating, and that internal friction may generate enough heat to keep the ocean liquid, while also driving geological activity deep beneath the seafloor. Computer models suggest that rocky material inside Europa could interact with seawater at high temperatures, potentially creating hydrothermal vents, similar to those found on Earth. If that is happening, the hidden ocean of Europa may not be a quiet, frozen abyss after all. It could be a dynamic environment, filled with chemical energy, warm, mineral-rich currents, and stable conditions that might allow microscopic life to survive, and if even the simplest organisms have managed to take hold within that alien ocean, then somewhere beneath Europa's frozen crust, far from sunlight and the warmth of the sun, an ecosystem may already be quietly evolving in the dark waters of a distant world. If energy and liquid water truly exist beneath the frozen shell of Europa, then the hidden ocean below may not be an empty world of dark water. It could be an ecosystem, slowly evolving in isolation for billions of years. Scientists often begin imagining Europa's potential life by looking at the most extreme environments on Earth, places where organisms survive under crushing pressure, freezing temperatures, and total darkness. In the deepest parts of Earth's oceans, life thrives around hydrothermal vents, where superheated water, rich in minerals, pours from the seafloor, supporting communities of bacteria, tube worms, and strange crustaceans that survive entirely without sunlight. If similar hydrothermal activity exists on the ocean floor of Europa, then microbial life could potentially survive there as well, feeding on chemical energy released from reactions between seawater and the Moon's rocky interior. These organisms would likely be extremely simple, perhaps similar to bacteria or archaea, microscopic life forms, drifting through the dark ocean currents beneath the ice. But over immense periods of time, evolution can produce surprising complexity. On Earth, life began as simple microbes, nearly 4 billion years ago, yet today, the oceans contain an incredible diversity of organisms, from tiny plankton to massive whales. If Europa's ocean has remained stable for long enough, some scientists cautiously speculate that more complex life forms could exist there as well. Perhaps small swimming organisms, soft-bodied creatures adapted to darkness, or life forms unlike anything found on Earth. Of course, these ideas remain hypothetical for now, because no spacecraft has yet directly explored the ocean hidden beneath Europa's icy crust. But future missions are designed to search for the clues that could reveal whether such life is even possible. One of the most important of these missions is Europa Clipper, a spacecraft built specifically to study Europa in unprecedented detail by repeatedly flying close to the Moon while orbiting the giant planet Jupiter. Europa Clipper will analyze the surface chemistry, map the thickness of the ice shell, and search for locations where material from the hidden ocean may be reaching the surface. If organic molecules or biological signatures are detected in those regions, it could be the first real hint that something may already be living in the dark waters. Beneath Europa's frozen surface, the search for life beneath the frozen shell of Europa is about to enter a new era with NASA's groundbreaking mission, Europa Clipper, set to launch in the near future. Unlike previous flybys, Europa Clipper is designed to explore the Moon in unprecedented detail, performing dozens of close passes, while orbiting the giant planet Jupiter, allowing scientists to study the surface and subsurface environment from multiple angles, equipped with ice-penetrating radar, high-resolution cameras, spectrometers, and magnetometers. The spacecraft will measure the thickness of Europa's ice shell, map fractures and ridges, and detect signs of water plumes erupting into space, tiny geysers that may carry materials directly from the hidden ocean below. By analyzing the chemistry of these plumes, scientists hope to identify salts, organic compounds, and other chemical fingerprints that could hint at biological activity deep beneath the ice. Even the Moon's magnetic field will be closely monitored to better understand the properties of the hidden ocean, its depth, salinity, and movement. Europa Clipper's instruments are so precise that, for the first time, humanity may be able to remotely taste the composition of a hidden alien ocean. Without ever landing, a leap in exploration that could redefine our understanding of where life can exist in the solar system. The mission will also examine how Jupiter's immense gravity continues to flex Europa, generating heat that keeps the ocean liquid, and possibly sustaining an environment where life could survive. Every flyby, every data point, every high-resolution image brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? Or is life quietly thriving in the dark alien oceans of a moon 390 million miles away? The anticipation is immense because if Europa Clipper discovers even the simplest chemical hints of life, it will mark one of the most extraordinary discoveries in human history, proving that the universe may be teeming with life in places we once thought impossible. As we look back at the frozen surface of Europa, it is easy to imagine a lifeless, silent world drifting through the dark, but the story beneath the ice tells a far more extraordinary tale. A vast ocean hidden beneath miles of ice, warmed by tidal forces from the giant planet Jupiter, stirred by chemical energy from hydrothermal vents on the ocean floor, creates the tantalizing possibility that life, however small, may exist far from sunlight, far from warmth, and far from our world, with NASA's Europa Clipper soon ready to explore this enigmatic moon. Humanity stands on the threshold of a discovery that could redefine everything we know about life in the cosmos, because wherever there is liquid water and energy, the universe may find a way to create life. Imagine microbial ecosystems drifting in the dark, tiny alien organisms surviving in total isolation, perhaps even evolving over billions of years. A reminder that life may not be unique to Earth. Europa challenges our understanding of habitability, forcing us to consider worlds that were once dismissed as barren, frozen wastelands. Worlds that may actually be teeming with possibilities beneath their icy crusts. And as we wait for the first detailed data from Europa Clipper, every crack, every ridge, every potential plume becomes a whisper from an alien ocean, inviting us to imagine, to wonder, and to dream. In the frozen silence of this distant moon, the universe reminds us that even in the darkest and coldest corners, life may quietly endure, and that our search for life beyond Earth has only just begun. The hidden ocean of Europa is more than water beneath ice. It is a mirror reflecting one of humanity's greatest questions. Are we truly alone, or is the universe filled with worlds where life quietly thrives, waiting for us to discover it?